All right, welcome to another L.A.M.E Creations video. This is going to be more or less a revisit of the Splunk.conf address I gave this previous June 2024 in Vegas. And so let's go give it. It was entitled Anomaly Detection So Easy Your Grandma Could Do It. No ML degree required. I'm not going to spend much time if you don't know who I am. I'm Troy Moore from Log Analysis Made Easy. Here's my contact information. All right. What we're going to discuss in this conference is breakout session is common baselines you might need. What are some things that you might need in your company? How to make those baselines. Let's give a demo. I'm not a death by PowerPoint person, so we're going to go into a live demo on this. What should you do after seeing this presentation and some gotchas to baselining? Let's discuss what baselining is. Baselining is the expected values or conditions against which all performances are compared. I'd given a definition to it. What is that in practice? Well, let's go the other way. Common baselines, let's discuss what some are. Maybe a hardware baseline. Can I get a software baseline? Can I get network ports and protocol baselines, user behavior baselines? I know that I've been working in the cyber world for many, many years, and I will ask as an auditor, do you by chance have an inventory? And you know what? It's a funny answer. Ask yourself, does your company have a network inventory? How thorough is it? How accurate is that network inventory? Well, if you don't have that, can you give me a baseline of what is on your network? A lot of people will tell you it's really difficult to give a baseline if you don't have a network inventory. And so you'll ask these questions and often you don't get the answers. I know I've told auditors year after year at the places I've worked, I don't have an inventory. I don't have those kind of things. What we're going to do in this presentation is we're going to show how Splunk and statistical models make you that hero. You can be the person who provides that inventory. You can be the person in this presentation who provides baselines and can show what is normal in our environment. And what I'm going to do is, in order to know what's normal, we need to look to the past. It sounds, hopefully this makes sense. If you don't know what's happening in the past, you won't be able to know what's normal. The, the past is what defines normalcy. And so what we can do is we can look at historical IP logs of the connections, and that can help us build a baseline. We can track the processes that have been running, and we can build a baseline. We can look at the ports used by systems historically, and we can build a baseline. We can track historical login events, and we can build a login event baseline. Splunk is a logging system. So if you've been getting those logs, then you have a tool now to build a baseline. So here is the concept that I'll need you to understand to be able to understand everything else. There are two methods for baselining. There's what I call the rolling window and the allow listing. Though the rolling window is the easiest way to start a baseline. It's, in my opinion, the most simple method. And the concept is we're going to use this little bar here. We've got an X, we're going to say this is a full line, and this is a timeline. So this might be one day, this might be a week, a month, a year, whatever the case may be, 3 months. And this is a historical part of that time. So let's say it's a one day. This could be 23 hours. This could be a week. So this could be 6 days. This could be a month. This could be 29 days. This could be a year. This could be 11 months or the case may be, and Y is a portion of that time that we're going to look at. The X portion will be our baseline. It'll be the historical events. The Y is what we're going to look at. We're going to say, hey, looking at all these events that have occurred, are there any events in Y that were not in this baseline? We're not in X. And if we do that, that's the definition of an anomaly. Anomalies are things that are not in your baseline. And so we can use a rolling window, and I will actually demo how to do that. The other one is allow listing, in which case we build a list of our baseline. Again, you've got to figure out how you're going to build that baseline, but if you do that, you put that list into a lookup file. We can do that by using the output lookup command, and then we use a lookup command in our logs, and we look for at all the logs coming in and say, are any of these logs, do we not have a matching pair of them in our lookup? And that would be an indication that this is a new anomalous event. All right, I've given the the PowerPoint presentation of that. We're now going to go into demo time. We want to demo this and show how this works in actual practice. Again, the queries are at the end of the presentation. I'm going to have to give a link to this PDF so you can just grab them if you want to use them, or just slow down the video. And I'm sorry, I'll have to record them that way. But anyway, that is what we're going to do. All right, for this demo, I wanted to make sure that any of you could go home and use this very same thing, the same data set. So I went and grabbed the Splunk's freely available boss of the SOC, referred to as bots, V3. You could go grab V2, V3, but you can, these things are going to work on your own data, but I wanted to make sure that you could do these very same scenarios when you went back home after this conference. So I went to Google, I type in bots V3 and I type GitHub, and that brings me back with this little link here. And it's just an app. You can go download it. It's a relatively large app because it contains all the data in an index already pre-indexed for you. So when you put this in here, you will have all the exact same data that I'm using in these queries, allowing you to easily be able to run the exact same thing in your own environment. And as you learn these queries, and you'll be able to use them elsewhere. All the documentation is right here. If you want to use any of these source types, they're all there available. And any of the required software that you'd need to run, any of the TAs, in order to be able to get your data to parse correctly. And we're going to primarily use the stream data and some network host logs. I'm going to jump over here into my environment. If I do a head 100 on this little command here, the spots v3 stream TCP, this is TCP network traffic. And I can see the network traffic. I can see certs going through. I can see connections with bytes in and bytes out, destination IP, source IP, des port, source port. And what I'm going to want to do is I want to baseline what is the normal IP traffic on my network. And thereby when I see abnormal IP traffic, I want to be alerted of it. And this has varying levels of success based on how random, how many new machines do your systems go out and visit. Workstations browsing the internet, they're going to have a lot of new IP addresses on an everyday basis. Servers, they're probably not going to go out and talk to a whole lot of different devices. Specialized devices such as OT, operation technology devices, they won't talk to a lot of machines. Their communication is pretty standard, so we can actually use that with to understand what's going on. If I come in here, let's run that query. The concept is I'm using an all-time query, but that's because I'm using this bots3 data. I have it in the notes in my PowerPoint how to turn this into a 90-day rolling window, but to make this work on the bots data, I had to actually set my time and do a little bit different. So I'll show you how that looks when I'm done. What we're going to do is index equals bots3, source type equals stream TCP, and what we're going to do here, this is the magic. We're just going to use a stats command. If I just did stats count by source IP, destination IP, that would give me every tuple that I've seen during this window. But if I put the stats min time, it's going to give me the earliest time, the smallest time value that it has seen in this tuple. And so this is giving me the earliest time this has popped up. So I've got a 90-day rolling window of tuples, and I will tag it with the earliest value seen. And if I do that, just like this, we'll see here comes back the earliest time. And if I undo that, now I'm going to come in here, I'm going to change it. Now I want to set a time. I want to know any time that this earliest time is greater. So in a normal thing, I might go back 86,400. That's the amount of seconds in a day. And so I might be looking for any new tuples in a day. I had to use this value here to move it to a new day based off this bots3 data. There's only 2.5 days worth of data in this bots data set. So but in order to make it work, so I had to put this specific timestamp in. Normally you would be using something like now minus 86,400, and I'll show that. But we're going to come down here, we'll go where earliest time is greater than now. And so if this first time it's been seen is greater than this thing, we're going to get the values back. If it's not, it won't show up. That's going to show, and if I do it like in a day timestamp, that'll only show me any of the new tuples that I've never seen in 90 days that have shown up today. So if I run this, we're going to flip this to fast mode. This will come back with all the tuples, brand new tuples that it's ever seen. I'm going to tell you this is still too large of a list, but part of this list would normally drop down. The fact is, the bigger the window you make, the less values you will have. If I'm looking at one day and I'm looking at the new values, you're going to have more results. If I go 90 days, the amount of new tuples will shrink. The bigger the window you have over here, the smaller the amount of results will come, because the more of those every now and then I go to will be included in my list. All right, this works. Let's grab something even a little easier to grasp. Now I'm showing this. These are processes. When I look at the processes, I'm looking at processes firing off. This is calculator being run, application frame host, crash plan desktop. These are processes on a machine. I want to know if there's new processes that have fired off. We're going back to the exact same query. We're going to, this time, we're grouping by instance, which is like this host name here. Sorry, instance is application frame host, and the host here. We're going to look at instance and host. And we're going to again grab the earliest time it was seen, and we're going to do an eval time when it's later, and then we're going to run it. So we're basically saying, hey, did I see this value early? What's the newest instances that have fired up in the last 24 hours that I've not seen over my time period? I run that, and you can see software running processes are going to be a lot less running on your system. And so we can run that. We get back the new processes that ran on this machine in the last 24 hours. And you can see what happens is SCP and SSH, those are brand new processes. If I was doing an investigation, all of a sudden machines, they've never done it, and they start involving SCP and SSH, that's probably something I want to be looking at. And so baselining and knowing what your systems run, and then when new processes fire, we can look at them and say, do I want to look at this? And we can build alerts off of it. Let's jump to another example, this time listening ports. The amount of ports that your machine is listening on should be very static. It's not going to change a ton. But if someone's opened up new applications, they might be opening up new listening ports. So you want to look at that. We can see here kind of the data coming back. We can see what machine, what ports are being opened, what they're listening on. If we use this very same concept, we can see min time as earliest time. This time we're looking at host and desk port. That's my pairing. That's what I'm looking for anomalies in. Grab the earliest time seen. Grab the window that I want to track. And we're going to say where earliest time is greater than now time. And in this one, make sure I flip it to verbose, because ports are really static. What a surprise, I'm going to get 0 results back. And that's actually what I'm looking for. That'll work out really well for me. So I've shown 3 examples here of how you can just grab any form of data. You look for what you want to find, as group it by what's normal, grab a big window, and then set your time to say anything that's occurred, that any new tuple that I see, new since this time. So we jump over here, we can quickly see this is how it would look like in real, this is how we do it at my place. Now, minus 86,400, last 90 days. We do the now minus 86,400. This says give me a 90-day window, go back 1 day. Very simple, we don't change much, and we just have that working. Now, if we come over here, we can do the exact same thing with our Splunk searches. We can come over here. We can take this to the next level, another way. Instead of saying, I want a 90-day window, there's a problem with a 90-day window. As soon as this anomalous event occurs, it's not going to be anomalous tomorrow. So what we can do is we can actually build a lookup and say, I'm going to make everything, I'm going to do the same concept, tuple them together. This time I don't need a time. I'm just going to grab all of my tuples, and I'm going to output lookup into a CSV, or I could do a KV store, and that becomes my window. And so new anomalous events will not repopulate unless I rerun this output lookup. So when I run this, I can do, so this would be, I'd build my baseline, and then I'd have a scheduled search or whatever that would search, and I'm going to do again stats count, and I'm going to do a lookup. I'm going to match on source IP and dest IP and output account, say as matched, and then I'm going to do where is null is matched, meaning I've got a source IP and destination IP but that are not in this lookup. That would make it null. And this will alert me. And if tomorrow the same source IP and destination IP appears, it will also alert me because as long as I don't update this lookup table, it will always be anomalous. And so there's pros and cons. This is a dynamic growing list. These ones I did over here with where earliest greater than. But over here, we're building a lookup list and we're doing a match. Same principle over here. We can take the perfmon process, exact same thing. We're going to output it to a CSV, and then we can set up a search to run every day where we do this lookup on instance, on host, and where it's matched. Or we can go to listening ports. We can output the lookup, and we can do this. One of the things you could do is you could actually take an evaluation of the two. You could actually take all the alerts that are popping each day and compare it to this list and see how much variance there is. So you could grab a 90-day table and then compare it to this output lookup. There's a lot of ways to value how much is changing on your environment. But the big key is use your historical data to create a baseline and search on it. All right, basic summary there. That video, we showed how we can use the stats command to baseline normal behavior from historical data. We use that baseline to determine new events. We're able to detect anomalous network connections, anomalous processes, and anomalous open ports. We then did those very same things with a CSV, and we baseline normal behavior, and we were able to use that CSV to detect the same thing, network connections, processes, hosts. So there are some gotchas that you need to be aware of. This is a really cool process, but as you start to get on it, don't let the gotchas get you. Don't let the quest for perfection get in the way of getting something done or having a good product. And the rolling window and allow list will get you a good answer. It's not perfect, and there'll be some gotchas along the road, but it's will get you most of the way. But now that you've got those baselines, now we're going to tell you some things you want to be careful of. Rolling window, you're going to be alerted one time that the anomalous connection occurred. And then, if you remember that X and Y, the X being the baseline, Y being the new events, the new events from Y are going to roll into X. And now that anomalous event will be part of your baseline. So you'll detect once, and then your anomaly is part of your baseline. So you need to be aware of that. And the frequency of the times you run the alert is run in a day that you need to make sure that how often you run this alert. Remember that you can have a small window. Say, I'm going to look at a 90-day window and I just want to look at 1 second. So the Y will be 1 second and the baseline will be 89 days, 23 hours, 59 minutes and 59 seconds, whatever. The fact is it's still going to look at 90 days worth of data. And so no matter how big your Y window is, it's always going to take the time it's required to run the entire X and Y window together. So you need to be aware that it can take some time to run this alert. It sounds great to run a really long, I want an all-time or on a real time, I want a year-long, 2 year. Recognize that if you run that every day, you're still running that query every day. So it's going to take some time up, and you want to make sure it doesn't impact the rest of the stuff you're doing. Allow listing on the other hand, it's going to run against whatever window. So if you look at the last 10 seconds, it's only going to run on a 10-second window. You were looking at the last hour, it's going to run on a 1 hour window. So it will run faster, but you need to remember that one, how am I going to build that baseline? How do I get new items into the baseline? You'll need to address that. And remember that a baseline, it's a CSV, a KV store. It's going to occupy space on your search head, and you can run out of disk space. You only have so much. Typically, we build a lot of space onto our indexers. Our search heads are not huge on disk space. Just be aware that as you start to build large baselines, one, you'll have performance issues. The more values it has to look against, the slower your search will run. And it's going to take up physical disk space on your machine. So that's something you need to just be aware of. I'm going to recommend a hybrid approach, and that's the ability to combine both. We're going to do a rolling window and allow listing. And so the basic concept is we're going to use your query goes here. So you're going to write your query, and then you're going to use this collect command. This is not about the different syntax in Splunk, but just know that if you use this pipe collect command, you will write to a summary index. Summary indexes are a form of indexing that do not cost you on an ingestion license. You can write to a summary index, and then you can query that index just like you could query any other index. And so you can save your results in an index. And the concept is, I typically, like if I want to build these, I might write every day a query, and I'm going to write it to the index, and it will timestamp it with today's information. Tomorrow will have tomorrow's information, and yesterday will have yesterday's information. And we can query it and search it. And so you'll basically write your query, you'll run the collect command, index equals summary, source, and give it a name. Then what you want to do is, now that you've done that, that's going to be building your alert. Then you're going to come in here and you're going to look at that summary data, and you're going to append to that those results that fired for that day. So you look at the last set of time it ran. So maybe you run this once a day. You look at yesterday's results. You put that in here, and then you'll use this append command, which will append the lookup. I said allow list. It should be a disallow list. That was a bad writing here. You gotta be careful of the descriptions you use. You're gonna grab a list of things you consider to be anomalous. So if you see these, you want to flag on them. It's not what I've done before the CSV, which is this is my normal baseline. These are bad events. I don't want these events. And so I'm going to do the input lookup, allow list.csv, and then I'm going to do a table on the matching fields. So what matching from this query over here, and then I'm going to stats count by the matching fields. That will basically dedupe. For those who are The dedupe command will remove the duplicates, but stats does the same thing, and it's more efficient. So if you want to write dedupe, you can, but I recommend that you learn the power of the stats command. It is fast. It's just the right command to use. So stats count by matching, this basically removing the duplicates. So if it was in this index, summary index, and it's in my lookup, we're not going to write it in twice. And then we'll write it to this allow list CSV, which will update it, which means all the new things that were found will be then written into this lookup, and then it will be updated. It'll have a new lookup with the results combined. So an example of that would be index equals bots v3, source type equals perf mon mk process, stats min time is earliest time max. This is all the exact same query. Nothing's really changed. The difference is, after I do this eval time, I'm not going to do this lookup. I'm going to use the name of this CSV. I'm going to do instance as instance, host as host, output instance as recurring. I need a value that shows, hey, I matched the CSV. And then I'm going to go and I actually changed this, I forgot, max time. I want a min time and a max time. And the reason being is the min time is looking to see if the value falls in the X of the XY on my rolling window. The max time is to find if it's in the Y area, and we'll explain that. So I still have the same where earliest time is greater than now time. That's going to say, hey, I've never seen this event before. Or recurring equals star, meaning, hey, I got a match on this value, and the latest time is greater than the now time, meaning it's in the Y section. That means this alert that is on my list of things I don't want to keep seeing, I don't want to allow, it just showed up again. That way, you'll be notified again that it occurred. You're updating your lookup file, and you're using a rolling window. And so you kind of get the best of both worlds, and you can use this as a method to automate keeping up to date on any of your alerts. And now we're going to demo that. I've got a video of it. We're going to go watch that, and then we'll come back. All right, so this is the hybrid approach that we've been talking about. It's going to look exactly like we did before. You've got yourself the normal query. We're going to just make some form of query here. This is going to build our processes, and then we're going to write a collect command. This collect command will write our results into a summary index, and that's the index equals summary, and then we go source equals new process. That's going to define the name of the source for this summary index. And so we're going to do that, run the results, and we can see that we got two values coming back. If we jump over here, this is where we're going to take that very same, we can see the summary index being run. There's my two results. We can query them just like any other index. And you'll notice index equals summary, source equals new process. Then we're going to use this append command. This append is going to add this lookup, this new process.csv, and then we're going to put in the table of the instance and the host. And I'm just going to do a stats count by instance host. That's basically going to dedupe. So it's going to take the index summary and the input lookup and make them one if there's any duplicates there, so I don't get them twice. That's what that command's going to do. It's faster than dedupe, and I'm going to output the lookup to new process.csv. And that's going to write that what was the original new process CSV, and it's going to update with any new fields coming from this summary index. So we can see that being run if I go over, and we're going to get that taken care of. We go run this. What it's going to do is it's going to grab the summary index stuff, and it's going to grab the stuff that was already in my CSV, and it's going to write them in there. And so now I have 4 values. And those all got written in the CSV. Now I'm going to write my query that I've been doing this rolling window all over again. We're going to do, the difference is I'm going to add a max time in there. It's not just going to be a min time, it's also going to be a max time, so I can look at the Y side of the equation. And then I'm going to do this lookup. New process, instance as instance, host as host, output instance as recurring. I need to make the output instance that shows me what matched on this lookup. It's kind of like a join command. It's going to join the CSV to the previous values, and whatever matches is going to be output. And I'm going to do the same like I've always been doing, earliest time greater than now time, and that's normal. And then we're going to add this recurring equals star. Recurring equals star means it matched on something. I have a value, and latest time is greater than now time. And that's going to look, is there a value in the Y field, and is it a recurring field? And if it is, that's going to alert. And so we can see that being run. And we're just going to see we're going to go back to those 2 fields. These two fields occurred during the new window, and they'll keep showing up as often as they occur. All right, we basically showed how we can combine those 2 approaches in a hybrid approach. We created our lookup of anomalous behavior so they don't get excluded. We use that to validate how much, and then there are other things like we can do. We can look at the results of one against the other, and we can see if there's changes in our environment, how much change is going on. There's a lot of things that this gives you abilities to gain more insights into. All right, so what's next? I've shown you how you can build baselines. I've shown you examples of them. I've given you multiple methods. What I want you to do is now look at your environment. Think right now, what do I have in my environment that I could baseline? What could I grab? What logs could I do? I could take that very same approach. And I want you to think about it right now, write it down, and let's go, go do it. This video is great, but if you don't take action on it, this video, it will not have served its full purpose. So take that time right now to think, what videos, what logs do I have that I can use, and what approach can I do to make a baseline and check for anomalous events? Thank you so much for your time, and I now open it up to questions.